Hello there, welcome to the AS Applied June 2023 paper. Here we're looking at question 1. The histogram is a frequency polygon. Below gives the weights in grams of 50 plums. Show that an estimate for the mean weight of the 50 plums is 63.72. Okay, so we're given a histogram here, and the key thing about a histogram is that the areas of the bars represent the frequency of the plums. So the area of the first bar is going to be 2 across, so the dimension is 2, the height is 3, so we're going to have 6 parts in this box here. And the next box is 2 by 12, so that's 24. And the next box is 2 by 8, which is 16, and 2 by 2 is 4. Let's just double check that that adds up to what we expect to be, which is 50, because sometimes it's proportional to, sometimes it's equal to. So we get 30, 46, 4, so that's 50, excellent. So this is the number of plums in each of the different categories. So we want to find a mean weight for these 50 plums, so that is to add up all your data and divide by how much data you have. In this case, we have 6 plums that are approximately, well, we'll have to use the average, which is the middle number of 61 grams. So 6 lots of plums, that's 61. Move on to the next box. 24 plums weigh approximately 63, or an average 63. 16 times 65, and 4 times 67. And we're going to grab our calculator and just double check that it all adds up, and then when we divide it by 50, we do get 63.72. Excellent. Okay, moving on to part B, calculate an estimate for the standard deviation of the 50 plums. Okay, so let's remind ourselves of the standard deviation formula. It is to add up the frequency times the data values squared divided by n minus the mean squared, and then we square root it for standard deviation. So let's do this calculation then. So it's very similar to the one above. The frequency will be 6, 24, 16 and 4, but now instead of just doing 61, 63, 65, 67, we square 61, square of 63, square of 65 and square of 67. So it's 6 times 61 squared, add 24 times 63 squared, add 16 times 65 squared, add 4 times 67 squared. We're going to add all of that up, divide it by 50, and then take away 63.72 squared. And I did this in preparation rather than doing this all on the video. When you calculate all of that, you do get 1.58795. We won't leave our answer like that. We'll leave it as 1.59 to 3 significant figures. Excellent. When in doubt in an A-level maths question, leave your answer to 3 significant figures. Moving on to part C now. Later it was discovered that the scales used to weigh the plums were broken. Each plum actually weighs 5 grams less than originally thought. State the effect this will have on the estimate for the standard deviation. Give a reason for your answer. Well, the answer to part C is that if the plums all weighed 5 grams less, then it will not affect the standard deviation. And the reason is that it will just move all of the data points down by 5. The spread of the data will not be changed. So there we are. So that's the answer to question C. And there we are. In total, that's the answer to question 1 with a total of 5 marks. Let's now move on to question 2.